This is going to be solving linear systems without graphing. The method we will learn first is called substitution. Called the substitution method. And we will learn another method called the elimination method. But we'll start with this one. And move on to the, some people find substitution, they like substitution best, and some people actually find that they like elimination best. The equations end up being a little easier to solve. Can you step outside the door until we're finished? Yeah, Emily, seriously, can you step outside the door until we're finished? Thank you. So, we'll do a little simpler example. Y equals 3x plus 2. And x plus 2y equals 11. Is a system of equations, a system of two linear equations. And these may be a little harder to graph anyway. I think the first one wouldn't be too hard to graph. The second one doesn't have integer x and y intercepts. I'm sorry, it has an integer x-intercept, doesn't have an integer y-intercept. So I think we'd have a little bit of hard time graphing these to start off with. So we'll use this algebraic method called substitution. This first line reads, y equals 3x plus 2. You can also think of that as y is the same thing as 3x plus 2. So y can be substituted for 3x plus 2. So when I have one of my variables isolated on one side of the equal sign, and in my other equation I don't have my variable isolated, what I do is I find that isolated variable, that y, in the second equation. There it is. And wherever I see a y now, I'm not going to write y, I'm going to write 3x plus 2. I'm going to rewrite this second equation as x plus 2. Don't write the y, write the 3x plus 2. But I don't want to write two numbers right next to each other. And that means 2 times y. So parentheses also mean times. Then I'll copy down the equals. Then I'll copy down the 11. Now I have an equation that doesn't have x's and y's in it. It just has x's. Now I can solve this equation for my x. So this is x plus, distribute the 2. 2 times 3x is 6x plus 2 times 2 is 4 equals 11. Next thing I'm going to do is called combining like terms. I will combine that x with that 6x. That's 1x plus 6x is how many x's? 7x. So this is 7x plus 4 equals 11. Do you know what x is? 1. Subtract the 4. I get 7x equals 1. 7x equals 7, so x is equal to 1. When solving systems, I need two answers. I have one of them already. X equals 1. To get the other answer, I go back to the other equation, is usually the easier equation to do, and I substitute that 1 in for the x. So this said y equals 3x plus 2. Now wherever I see an x, I'm going to replace it with a 1. So this is y is equal to 3 times 1 plus 2, which means y is equal to 5. So my answer is x equals 1, y equals 5, or I can write that as what's called an ordered pair, 1, 5. Okay. Let's try one of them from the homework. See if we can get through one of them from the homework. So your homework, this is getting kind of late now. Your homework is on page 439. Three through 8. It says 18, don't do 18. And page 441, 4 through 6. Okay, let's try number 3. X equals 17 minus 4y. And y equals x minus 2. Okay? The top equation has the x all by itself on the left side of the equal sign, so I think that I will replace my x in the second equation with that 17 minus 4y. So I'm going to rewrite the second equation as y equals, I won't write x, I'll write 17 minus 4y, and then I have to write that minus 2. Now I have to combine like terms. So I get y equals, combine the 17 and the minus 2 to get 15 minus 4y. I have y's on both sides of the equation, so I need y on only one side of the equation, so I'm going to add 4 y's to both sides. Y plus 4y is 5y equals 15. So y is 3. Okay? Halfway done. I take that 3 and I substitute it back into the other equation. X equals 17 minus 4y. Wherever I see a y, I'm going to put a 3. So x is 17 minus 4 times 3. So x is 17 minus 12, which means x is 5. So my solution is x is 5, y is 3, and I can write that as 5, 3. Not 3, 5. Write the x first and then the y. All right.